So good morning, everyone. We are going to talk about electronic configuration and how to find its quantum numbers. So for our objectives, to identify the electronic configuration of a given electron and to predict the set of quantum numbers of a given electron. First, we define what is electronic configuration. An electronic configuration of an atom is a representation of its arrangement and distribution. Electron configuration is used not only to describe the orbitals of an atom in its ground state, but also to represent the cations or anions by reflecting loss or gain of electrons in their subsequent orbitals. For quantum numbers, it is described the values of conserved quantities of a quantum system. The four types of quantum numbers is the principal quantum number, angular quantum number, magnetic quantum number, and spin quantum number. For the principal quantum number, this describes the energy level of an electron. The value of n ranges from 1, the electron shell or energy level containing the outermost electron of the atom. The angular momentum quantum number, it is a quantum number is also ginatawag din siya na azimuthal quantum number. This describes the shape of the orbital and the magnitude of orbital angular momentum. So mabalaan nimo kung ang inyong angular momentum quantum number sa parisya na formula. Ang S is equivalent siya sa 0, P is equivalent siya sa 1, D is equivalent siya sa 2, and F is equivalent to 3. So kung ang nakabutang, like for example, SD8, so letter D man na dito, so 2 iyahang angular momentum quantum number. So magnetic quantum number, this describes the orientation of the electron cloud. The value of magnetic quantum number depends on the value of the angular quantum number. So ang iyahang formula, marag given god anak kay S equals to 0, P is equals to -1, 0, positive 1. Sa D kay -2, -1, 0, positive 1, positive 2. F is equals to -3, -2, -1, 0, positive 1, positive 2, positive 3. So mao ni siya tong arrow guys katong for example ang kuan di ba 3D 3D8 ano kunyari. So letter D, so -2, wait lang. Mag drawing na lang ko. So di ba negative nakuha oy. Wait lang. So diba, -2, -1, 0, 1, 2. So magdawing kag box. For example, di ba 3D8. 3D8. Basta 3D8 na siya. 8 man. So, wait lang. 1. Wala siya -2, -1, 0, 1, and 2. So, ang arrow niya kay 1, bilang kag 8. Pero dapat mag-start ka sa og bilang og arrow based sa upwards na arrow bago ka mag-proceed sa downward. So, 1, 2, 3, 4, 5, 6, 7, 8. So sa 8 man siya nag-stop. So ang inyong magnetic quantum number sa 3D8 kay -2 ay 0. 0 siya. For the spin quantum number, this describes the spin of the electron values. Ang value niya kay for example nagbilang ka tapos nag-stop siya sa downward na arrow, ang imuhang spin quantum number is -2/3. ay negative 1 over 2 or tapos kung sa upward lang po siya nag-stop, up positive 1 over 2. So, pare siya, its values can be positive 1 over 2 kung upward ang arrow. Pag negative 1 over 2 or negative 1 half, nag-represent siya sa downward na arrow. So, for the next, kay ang are. Sa nickel, 28. So, iyang electronic configuration kay 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d8. Actually, yung mga man listed ani is naka-kay periodic table kay makita lang man diri ang iyahang ang guide. Ang S kay siya, pwede siya maging 2 lang gid siya actually. Tapos ang P kay it goes up to 6 and ang D goes up to 10 and F goes up to 14. So sa principal quantum number na is 4. Kaya kung mag-base ko sa periodic table, ang nickel kay kasi sa 4 sa period na siya dire. So sa nickel, ang angular momentum quantum number sa nickel is 2. Kay sa given, di ba, 3d8, so ang d kay 2 is equivalent to 2 man, so 2 siya. Sa m kay 8, per exponent niya kay 8, so magbilang kag 8 na arrows. 1, wait lang. 1, 2, 3, 4, 5, 6, 7, 8. So nag-stop siya sa 0. Mo anang 0 ang inyong magnetic quantum number. Sa spin kay negative 1 over 2 because nag-stop siya bilang sa downward na arrow. Sa calcium, ang iyang electronic configuration kay 4, kay sa 4 man gyapon siya nga period. So 4 gyapon siya. Sa inyong angular momentum quantum number 0, kay ang last di ba na kuan kay S, so 4s2, so letter S kuan karang equivalent siya sa 0. S is equivalent to 0 man to sa given kaganina. So ang magnetic quantum number sa calcium is 0 pod kay di ba 2 lang man, so dual na po dapat siya ka arrow, so bilang lang po ka, tapos nag-stop yapon siya sa 0, so 0 yapon siya. So sa iyang spin quantum number is negative 1 over 2 or negative 1 half, actually typo na siya, wala na siya dash sa last. 0 kay 0 ay ang kay nag-stop man kag bilang sa ang iyang arrow kay sa downward, so negative 1 over 2. Sa phosphorus, ang iyahang principal quantum number is 3. Kay ang phosphorus sa kita ko siya sa period 3 sa periodic table. Tapos ang angular momentum quantum number is 0. Okay. Ang last niya nga wait lang. Ang ang kuan di sa angular momentum quantum number is 1 kay 3p3. So p is equivalent to 1. So ang next is magnetic quantum number sa phosphorus is positive 1 kay nag-stop siya sa arrow na pa-upward. First, the spin quantum number of the phosphorus is positive 1 half because nag-stop siya o bilang sa pa-upward na arrow. So for the next report, I will be giving the spotlight to Miss Villanueva.
Good morning, ma'am. Good morning, class. Am I audible po? Okay, continuing with the reporting of Mr. Magallanes, for number 4, we have the given of chlorine, and its atomic number is 17. We were able to have this electronic configuration with the help of the guidance. So we have 1s2, 2s2, 2p6, 3s2, and 3p5. You may have noticed that our last electronic configuration, which is 3p5, it was said that the P can accommodate 6 electrons, yet we wrote 5 here. Why? Because if we will add all of that electronic configuration, all of that number of electron in the orbital, it will be equal to 17. So if we will write 6, it will be equal to 18. So it will not be matched. Now, proceeding with the principal quantum number, or our main energy level, we will just be looking at its bigger number. So looking at the electronic configuration, our bigger number or biggest number is 3. Thus, n is equal to 3. Now for angular quantum number, it is the subshell of the electron energy level. So looking at the last letter of our electronic configuration, which is letter P, and the value of P for the angular quantum number is equal to 1. Keep in mind that the S is equal to 0, P is equals to 1, B is equals to 2, and F is equals to 3. So since we have the last letter P and its value is 1, therefore L is equals to 1. Now moving on for magnetic quantum number, or the orientation of orbital and nucleus, we use this box as a guidance to determine the magnetic quantum number. So why did we write 3 box? Since our last letter is P and its orbit is equals to 3, we will be illustrating 3 boxes. Now, for these arrows, for this value down here, -1, 0, and 1, for the left side is the -1 and the right side is positive, and at the center is 0, just like if we will be drawing x-axis in a Cartesian plane. Now for the arrow, we will be starting at the left to right, then back again to left. Starting with drawing upward, we will be looking at the number of electron in our last number, which is 5. Okay, so 5 means 5 arrows starting from left upward, 1, 2, 3. Now since we only have 3 boxes, we will now proceed on drawing downward. So 4 and 5. We stop here at the value of 0, therefore our M is equals to 0. Now we should keep in mind that the orientation of our arrow is downward. So our spin quantum number will be negative since it is downward. So S is equals to -1/2. Now moving on for the number 5, we have Ag, and the atomic number is 47. Now we will just be doing it again for the electronic configuration. I advise you to have your copy with the electronic configuration so that you can follow along. So with the help of these arrows, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, and 4d9. And now, for the D, it was said that D can accommodate 10 electrons, but we write 9 because it will be sobra na. If we will add this all of these electrons. Now moving on for the principal quantum number, again the biggest number, since we have number 5 here, therefore n is equals to 5. Now for the angular quantum number, our last letter is D, and the value of D is equals to 2, therefore L is equals to 2. Now for the M, our Since our last letter is B and the number of orbits is 5, therefore we will be having 5 boxes. Now, the electron in the orbital of our last letter is 9. There, we will also be having 9 arrows following from up. We will starting from upward 1, 2, 3, 4, 5. Then going back to the first box, but this time downward 6, 7, 8, 9. And this time we stop at the value of 1. Therefore, our M it will be equal to 1. And its orientation is downward, its pattern is downward, meaning it will be negative. So our S is negative 1/2. For the last number, which is the Na plus, and the atomic number is 11. This given is different from the other since it has a charge, and as you notice, we have positive there, and understandable that it has a 1 value with it. So positive 1 charge, meaning we will subtract the atomic number to 1. Since we have 11 here and we have a positive 1 charge, we will just be subtracting it, 11 minus 1. So we have 10. We should have a total of 10 electrons in the orbital. So following the electronic configuration, we have 1s2, 2s2, and 2p6. That's why if you will add these 3, we will have the result of 10 atomic mass. Now for the principal quantum number, again, the biggest number is 2, therefore n is equals to 2. For the angular quantum, the last letter, our last letter is P, and its value is 1, therefore L is equals to 1. And for the M, we have 3 boxes as a guidance and 6 arrows. We by looking at our last electronic configuration. 6 arrows starting from left, 1, 2, 3, then come back again, but this time downward, 4, 5, 6. Now, still the ending is downward, therefore, M muna. Our value for M is 1, and since it is downward, our S will be equal to negative 1/2. And that's it for my part. I will be giving it to next reporter.
Ma'am,
Yes.
brownout po daw ilagilot kanya itong report, ma'am.
Salo na lang muna. Other group mates.
I will just continue with the reporting since my co-group is not present.
Okay.
For now, moving on with the principles, first is Pauli's exclusion principle. The Pauli exclusion principle states that in a single atom, no 2 electrons will have an identical set or same quantum numbers. To put in simple terms, every electron should have or be in its own unique state. There are 2 salient rules that the Pauli exclusion principle follows, and these are: only 2 electrons can occupy the same orbital. So, hindi siya pwede tatlo and more. Only 2 electrons. The second one is the two electrons that are present in the same orbital must have opposite spins, or they should be antiparallel. Next. Okay. Antiparallel means pala opposite. So, hindi siya pwede na dalawang direction. Now, for example, we can further reduce the successive larger elements will have shells of successively higher energy. The number of electrons in the outermost shell is also directly related to the different chemical properties that elements possess. Elements with the same number of electrons in the outermost shell will have similar properties. We can see here at the first figure, the helium 1s orbital electron spin. It was indicated that the same pattern is, or same way is not, hindi siya pwede. So, moving on, we can take a neutral helium atom as a common Pauli exclusion principle example. The atom has two bound electrons and they occupy the outermost shell with opposite spins. Here, we will find that the two electrons are in the 1s subshell, where n is equals to 1, L is equals to 0, and Ml is equals to 0. Next. For Heisenberg's uncertainty principle, we have here the electron of position times momentum more than or equal to h over 4 pi. The more we know about the particle's position, the less we know about its momentum. And the more we know the momentum of a particle, the less we know about its position. So we can see here the figure at the right side, the uncertainty principle. The position will be multiplied to momentum. Why? Because we can know position or momentum accurately. We can, nasa opposite direction sila. The position will be either up. If our position is upward, our momentum will be downward, and vice versa. For the next slide, I am giving this part for Mr. Magallanes, for another reporter.
Good morning, everyone. I am Rashid Claire, the reporter of Aufbau Building Up Principle. So, Aufbau Principle dictates the manner in which electrons are filled in the atomic orbitals of an atom in its ground state. It states that electrons are filled into atomic orbitals in the increasing order of orbital energy level. So according to the Aufbau principle, the available atomic orbitals with the lowest energy levels are occupied before those with higher energy levels. The term comes from the German Aufbau, which means built up or construction. The atom, ion, or molecule forms the most stable electron configuration as a result. Therefore, Aufbau rule asserts that the filling of the different electron configuration subshell follows the N plus L rule in sequence of increasing energy. Next. Next po. So the Aufbau principle can be used to understand the location of electrons in an atom and their corresponding energy level. So we can illustrate Aufbau principle in finding the energy of orbitals. So in finding energy of orbitals, we use N plus L. So the first example is 3s and 4p. In 3s, we have N is equals to 3, L is equals to 0, N plus L, or 3 plus 0 is equals to 3. And in 4p, n is equals to 4, L is equals to 1, n plus L, or 4 plus 1 is equals to 5. So therefore, 4p has more energy than 3s because the n plus L of 4p is greater than 3s. So therefore, according to the off-bow principle, electrons fills the 3s orbitals due to lower energy. So the next example is 2p and 4s. So in 2p, the n is equals to 2, L is equals to 1, then it has a value of 3. And in 4s, n is equals to 4, L is equals to 0, and it has a value of 4. So therefore, according to the Aufbau principle also, electrons fills the 2p orbital first, then 4s. And in 3p and 4s naman po is, this is a special case happen because the value is same. So 3p has a value of 4 and 4s has a value of 4 also. But do they have same energy? So the answer is no. In such case, when you encounter same value of n plus L of two orbitals, always decide on the principal quantum number, or n. So 3p is 3p has a lower energy. So next. So here are some examples. So writing the electron configuration of sulfur. So the atomic number of sulfur is 16, implying that it holds a total of 16 electrons. So as per the Aufbau principle, two of these electrons are present in the 1s subshell. 8 of them are present in the 2s and 2p subshell, and the remaining are distributed in the 3s and 3p subshells. Therefore, the electron configuration of sulfur can be written as 1s2, 2s2, 2p6, 3s2, and 3p4. So as you can see, it starts with lowest energy to higher energy. So writing the electron configuration of nitrogen. So the element nitrogen has 7 electrons, and the electrons are filled into the 1s, 2s, and 2p orbitals. So the electron configuration of nitrogen can be written as 1s2, 2s2, 2p3. And next. Next po. So next is Hund's rule of maximum multiplicity. So as you consider oxygen atom, the atomic number is 8. The electric configuration of an oxygen is 1s2, 2s2, and 2p4. So according to the Aufbau principle, which we learned in the previous slide, the energy of 1s is smaller than uh, 2s, then 2s smaller than 2p. So 1s has one orbital, 2s has also one, and 2p4 has three orbitals. So the important how this electron should be placed, how this electron should be placed in orbitals. So, well, this problem is solved by the Hans rule principle. It states the two important. First is the every orbital in a subshell is singly filled with one orbital before any orbital is doubly filled. The number two, all electrons in singly filled orbitals have the same spin. So now we can easily fill the orbital of oxygen using the Hund's rule. So the two electrons of 1s can fill one electron in upward direction and downward direction, and also in 2s2 we can fill one electron in upward direction and downward direction. So therefore, always remember there are two tips in Hund's rule of maximum multiplicity, which is it is a pairing of electrons in orbitals, and electrons tend to remain unpaired as far as possible. So next. So these are example. So Consider the aluminum has 13 atomic number. So according to the Aufbau principle, the increasing number of energy is 1s, 1s, 2s, 2p, 3s, 3p. 1s and 2s can accommodate 2 electrons, 2p can accommodate 6 electrons, 3s can accommodate 2 electrons, and 3p can accommodate 1. So we know that 1s has 1 orbital, so 2 electrons filled with opposite direction. 2s has 1 orbital also, so 2 electrons filled with opposite direction also. 2p has 3 orbital. According to the Hund's rule, 3 orbitals are singly filled in one direction. Then secondly, they are doubly filled with opposite direction. So 3 has also one, orbital. So 2 electrons are filled in opposite direction. And again, 3p has 1 orbital. It but there is 1 electron left. I no, it's 3p has a 3 orbital, but there is 1 electron left. Thus, you can place this 1 electron either in any orbital because they have the same energy. So now we successfully configure the aluminum using the Hund's rule, and that's it.
Is that the last part? Last
Opo,
part?
ma'am.
Okay. So, sino yung wala? Si Brian? Tama ba? How about Miss Parocha? Miss Parocha is also...
Nagalag daw siya, ma'am.
Okay.
Connecting siya lagi, ma'am. Data lang po kasi gamit.
Okay. So, she's not around also ngayon? Wala siya, no? Okay, sige. Can you share again the PPT? Let us check. Saan ko lang siya i-check. Okay, starting from the first, number 1. Let us check. Sige. Ayan. Okay, so this one is for the electron configuration and quantum numbers. You are allowed, class, to have your index card for the pattern or the arrangement of the orbitals for the electron configuration. So I hope by now you have that index card. Let us start. Let's see if they have the correct answers here. We'll start with nickel. Nickel is 2859. Do not forget that in the electron configuration, you always use the atomic number. And most of the time, the atomic number is smaller than the atomic mass. Therefore, for nickel, 28 is the atomic number and 59 is the atomic mass. We will be using the atomic number because that represents the number of protons. But for a neutral element, meaning an element without a charge, the number of protons is equal to the number of electrons. So again, we can use the atomic number. So we have here 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, that's 20 na. Okay, plus 3d8. So this one is a total of 28. Do not forget, S can accommodate a total of 2 electrons, P can accommodate 6, and then B can accommodate 10. And lastly, F can accommodate 14. But in the case of nickel, since you have 20 here up to 4s2, you only need 8 na lang. So no need to actually fill in everything. So 8 na lang siya ang last. So this one, the electron configuration is correct. For the principal quantum number, you have to see the pinaka large na number for the period. Actually, this one, ito siya. Itong mga number na ito will represent the energy levels being occupied by the electron. And the largest number there will be the principal quantum number. And that will be equivalent to the number of period where the element belongs in the periodic table. So if you look at the periodic table, nickel belongs to the 4th period. So this one is correct. Now, for the azimuthal or angular quantum number, the magnetic and the spin, we will only look at the last configuration. Now for the L, that will be represented by the subshell and yung mga letters SPDF, and meron tayong mga corresponding numbers that will represent this subshell. So starting from S, you have 1, 2, and 3. Now this one is D. So the number that represents D is 2. So for the azimuthal or angular quantum number, this is correct, 2. And for the magnetic quantum number, that will be dependent to the azimuthal quantum number. Since that is 2, it means na D yan siya, meron tayong 5 orbitals. So as you can see in the table, you have there 1, 2, 3, 4, and 5 orbitals. We will be filling this with the electrons found in the last configuration, and we will follow this numbering. Pag na-confuse kayo, always start with 0 class, lagay niyo siya at the center, and then going to the right, just write positive numbers starting from 1, and to the left we have negative numbers. Pero when filling this, we will be looking at this number 8, meaning we have 8 electrons in the last electron configuration, and then if i-fill mo siya singly first, meaning isa-isa muna. So we have 1, 2, 3, 4, 5 before ka mag-pair, pero the pair should be in the opposite spin. So meaning we are going down. So we have 6, 7, and 8. So kung saan mo last nilagay yung last electron din, that will be the magnetic quantum number. So this one is 0. So this is correct. And then for the spin quantum number, this refers to the spin of the last electron also that you wrote for the magnetic quantum number. And then yung values na ginagamit natin here is positive 1/2 or negative 1/2. Actually, it can be other numbers, but for the sake na uniform tayong lahat, let's just use 1/2. If it's going up, it's positive 1/2. If going down, negative 1/2. Now, since this one is going down, so this is correct also, negative 1/2. Do you have questions for number 1? Wala? Okay, sige, let us move on. If you have questions, you can send your questions sa chat, ha? So next, we'll be moving on to calcium. Calcium is 20 and 40. So 20 is the atomic number. Ito yung gagamitin natin for the electron configuration. So we have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. This is a total of 20. So this is correct. Okay, so sa 4s2 tayo mag-e-end. Now, for the principal quantum number, you can see you have here the largest 4 for the energy level. So that's the principal quantum number. You can confirm this in your periodic table. Look at calcium. It belongs to the period number 4. Now, starting from the azimuthal or angular quantum number, let's look at the last configuration. That is S. S here. So when you say S, it is represented by the number 0. So that this one is correct. Now for the magnetic quantum number, the S subshell only has 1 orbital. So diretso na siya class 0. But if you fill in, we have 2 electrons here. So you have 1 and 2. Nevertheless, you will still have 0 here. Kapag ka 0 yung L, automatic 0 din yung M. Kasi isang orbital lang talaga siya. Now, dito tayo magkakaiba for the spin quantum number. Since we have 2 electrons here, the last electron is spinning down. So this is correct, negative 1/2. Okay? For number 3, this is 3115 phosphorus. So, syempre, we will be using the 15. So, we have 1s2, 2s2, 2p6. That's 10 already. Plus 2. And then, 3 na lang ang kulang. So, 3p3 ang last. So, yes, this one is also correct. Now, for the principal quantum number, yes, the largest there is 3. We have 2 3s here. You don't add that, ha? 3 lang talaga siya. So, the last configuration, that's 3p3. P is represented by the number 1. Now, for the magnetic quantum number, P has 3 orbitals. You can fill in Here, the electrons, we have 3 electrons in the last configuration. So you have 1, 2, and 3. If-fill in mo siya, the last electron is found here sa orbital number 1. So the magnetic quantum number is 1. And it's going up, so it's positive 1/2. So all the answers from numbers 1 to 3 are correct. Any question or clarification from the class? Or if you find something confusing, you can raise your questions now so that we can clarify. Wala na. So sige, let us move on to the next set of given. So the next one is chlorine 1735. You have 17 here. So let's count. 1s2, 2s2, 2p6, that's 10 plus 2. So kulang lang 5. So this is 3p5. So yes, this one is correct. Now the largest number is 3 again. So n is 3. For the angular quantum number, this is p here. Let me write again the SPDF. This is 0, 1, 2, and 3. Okay? So p na siya, so that is 1. And then P has 3 orbitals. We will be filling in the 5 electrons here, starting from -1, -0, and then 1 before you are going to pair, since we have a total of 5. So the last electron is found here sa 0 na orbital. So magnetic quantum number is 0. And it's going down. So this is also correct, -1/2. So tama lahat for number 4. Now for number 5, medyo madami-dami ito. It's 47. Hindi 108 ha, it's 47. It should be the atomic number. So let's see. This is a total of 10 here. 1s2, 2s2, 2p6. Plus 10 here. 3s2, 3p6. 4s2. And then plus 10. That's 30 already. After 3d10, we'll have the 4p, 4p6, 5s2. So this is 38 now. Ilan na lang ang kulang? 9. So after 5s2, that's where you have the 4d, pero kulang ng 9. So yes, it's 4d, 9. So this one is correct. Okay? This one is correct. Medyo mahaba lang siya. Now, what's the largest number here? The largest number is 5. So we have n is equal to 5. So look at the periodic table. Silver belongs to the period number 5. So when looking at the principal quantum number, it doesn't matter if it is found in the center or in the terminal or the end. Basta pinakamalaki siya na energy level, that will be your principal quantum number. Now again, starting from the azimuthal, we will be looking at the last configuration. So it's a D, and D is represented by 2. So this is correct. And D has 5 orbitals. So 1, 2, 3, 4, 5. We will be filling in the last set of electrons. We have a total of 9. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. So the last one is found sa orbital na +1. So this is correct. And it's going down. So the spin is -1/2. So do not forget to fill in the orbital singly first before ka mag-pair up. And the pairing is opposite yung spin. Okay? Now, lastly, we have number 6, but this time we have a charge. So you can still use class the atomic number, but you have to consider the charge. So anong ibig sabihin pag positive yung charge? It means you have more electrons, more protons. You have more protons here. Pag negative naman, you have more electrons. Okay, you have more electrons. Now this time, sodium is +1. Wait lang ha. Let me answer this. Kadali lang yun. Okay, wait lang, class. 1 minute. Okay, let us continue. Sorry for the interruption. It was actually urgent, so I need to take that. Sige, let's have sodium. Again, this is positive 1. The 11 here means it has 11 protons, but you have to consider the positive 1. It means meron siyang more protons than the electrons. So if you look at the electrons here, magma-minus ka lang ng 1. So kung ano yung charge na yun, i-minus mo. So meron itong 10 electrons. So yun lang yung inyong tandaan. And ito yung gagawa natin ng electron configuration. At the 11 ha, kasi that is 4 protons. So we have a total of 10, 1s2, 2s2, 2p6. So yes, this is correct. And the last energy shell na na-occupy niya is 2. So this is correct also. And the last configuration, pa-admit, wala man si Brian nag-enter sa Zoom. So hindi ko siya ma-admit. Okay, and then this is P, right? So P is represented by 1. And P has 3 orbitals. Dito natin ilalagay yung 6 electrons. Isa-isa muna. So you have 3 and another 3 going down. So the last one is found sa positive 1 na orbital. It's going down. So it's negative 1/2. So yes, the reporters got the correct answers for all the given. Ito yung last, diba? Number 6. Tama. Okay. Can you pa-next ng slide doon sa mga principles natin? Okay. So ito yung mga principles, class, governing the quantum numbers. You just have to understand what principle yung nagsasabi ng bawat steps na ginawa natin for the quantum number. Just like sa Paul's exclusion principle. When you say Paul's exclusion principle, it states there that no two electrons have the same set of quantum numbers. So for example, sodium and potassium, hindi sila magkakaroon, class, ng the same set of quantum number. Pwede silang magkapareha ng principal, ng azimuthal or angular, and magnetic, pero may pagkakaiba talaga, especially for the spin. So hindi again pwede na dalawang sets of electron magkapareho ng quantum numbers. So magkaiba talaga sila. Pwedeng magkapareho sa tatlo pero meron talagang isa na different. And it was also according to Pauli na yung isang orbital can accommodate 2 electrons only. So anong ibig sabihin yan? Yung S subshell meron siyang isang orbital. So ang isang orbital can only accommodate 2. That is also true for P. Though P can accommodate 6 electrons, subshell kasi itong P na ito, pero meron siyang 3 orbital. And bawat orbital, class, again, can only accommodate 2 electrons. So yan yung principle ni Pauli. And the 2 electrons that are present in the same orbital must have opposite spins, or they should be anti-parallel. So when you say anti-parallel, yung spin nila hindi pwede na magkapareho. So kagaya nito, dalawang electrons lang sa isang orbital. One should spin upward and the other one should spin downwards. Yun yung sinasabing anti-parallel. So you have to know sino nagsabi ng principle na yan. So in this case, we have here the PAULI'S exclusion principle. Pwede pa next. Ayan. Okay. Next na lang kasi this is just an example, right? Diniscuss ito kanina na the other one should spin up and then the other one should spin down. But anyway, we only have 2 electrons for each orbital. Now for Heisenberg's uncertainty principle, sa Heisenberg naman, ang tandaan nyo lang, may word siya dyan na uncertainty, meaning we don't really know simultaneously the position and momentum of the electrons. So your keyword there is uncertainty. We don't know. We cannot actually predict both the momentum and the position. We can predict the position but not the momentum, or the other way around. We can predict the momentum but not the position. That's Heisenberg's uncertainty principle. You don't need to compute for the equation. You just need to understand ano ang sinasabi ni Heisenberg. Okay? So yung position, pwede nating malaman, pero we don't know where the electron is going. If it's going down or it's going up. Or kung momentum yung alam natin, hindi natin talaga malalaman yung position kasi nga it's moving. Okay? Next principle. I think it's the Aufbau principle. Okay, so for the Aufbau building up principle, from the word building up, itong pattern na ito na ginagamit natin for the electron configuration was actually because of this principle. It states na we have to fill in the lower energy shell first before going up. So again, lower energy level first na orbital before tayo doon sa higher or larger energy level. So yung ifa-follow natin in the prediction kung paano natin ma-predict kung lower energy level ba yan siya or higher energy level is just N plus yung ating energy shell. Subshell. Wait, let me rewrite it. Paano natin siya malalaman kung higher energy level ba siya? So, N plus the subshell, kagaya ng 1s. Go back to yung sa angular quantum number, yung numbers na nagre-represent nitong mga subshell na ito. So, N is, remember, itong kasama niya na number, example, 1s. 1s class, to compute for the energy level, you just have to add 1, that's the N, plus the subshell. S is, diba, represented by 0, so this is 1. So again, the energy level for 1s is just 1. For the 2s, syempre you have 2 there for the N, plus the subshell, S is still 0, so this is 2 now. So kaya mauuna talaga i-fill in class sa pattern natin si 1s kaysa kay 2s. That's how you know the energy level. So again, lower energy level first before higher energy level. So for example, for the 3s, ganun pa rin. 3s is 3 plus 0, that's 3. And then for 2p, that's 2 plus p is 1. Kung nakita niyo sa screen class, pareho sila ng energy level. But the rule is if you encounter the same energy level, you go back to the principal quantum number. The one that has the larger principal quantum number will be regarded as higher energy level. So if you look at our pattern, after 2s, we will have the 2p. Kasi parehas sila ng energy level, pero we will regard again the higher principal quantum number as higher energy level. So that is again according to the Aufbau principle. Lower energy level first before increasing to higher energy level. Okay, questions for the three principles so far? Wala. Sige, let us have the last one. And that's the Hans rule of maximum multiplicity. Next ako ng slide, please. Okay, so, sige pa. Yan, ay, wait. Ayan, Hans rule of maximum multiplicity. Si Hans naman, yung nagsabi na isa-isa muna before pairing up. So, di ba, pag nagpe-predict tayo ng magnetic quantum number, nilalagay natin yung mga orbitals, tapos i-fill in natin yung electrons. Pero pag fill in natin, sa bawat electrons, sa isang orbital, isang electron muna before tayo mag-pair up. Again, that is according to Hans rule. And then, just like the Pauli's exclusion principle, Hans rule also states that the two electrons in each orbital should have opposite spin. So, kapag meron tayong tatlong orbital, isa-isa muna, tapos magkaparehas sila ng spin. If it's going up silang lahat. Tapos pag magpe-pair up na tayo, going down na siya. Okay? So again, that is according to Hans rule of maximum multiplicity. So I hope naintindihan yung apat na principles that we follow when we are going to predict the sets of quantum numbers. Questions so far? Wala. How about the others? Kasi natulog na ng uban din, ha? Kaya na nakatingog. I hope nagkasinabot ta aning atong electron configuration and the sets of quantum numbers. Wala na? So we will have our quiz for this. I will give you 1 hour to prepare, or if okay na mo ma'am, nakasabot na ko ani. So you can just eat there or whatever you want to do for the 1 hour na break. And then just go back here after 1 hour. So it's 8:36. Ano na lang, please be back here at 9:40 para dili bungkag. Okay, para dili bungkag, 9:40 please be back here, and then we will have our quiz. Our quiz will be file upload, so you have to prepare your sheet of paper. You can have your index card for the pattern though later. Pwede malaman ang score sa last quiz. I think wala pa ako nag-check sa last quiz. Okay? Wala pa ako mahatag na score, kaya wala pa ako nag-check. Let me see. Yeah, wala pa ako nag-check. Ibang section mo na-check ko. Yeah. So wala pa ako naka-check sa inyong section. So pahintay na lang.